A sensational claim has recently gone viral across the internet. Researchers state they mapped a massive, interconnected underground complex stretching 2 kilometers beneath the Giza pyramids. According to the team known as the Khafre-Sar project, these subterranean structures are located at an extreme depth of 648 meters, or over 2,100 feet, below the plateau's surface. The researchers report finding highly specific geometries buried in the rock, mapping 2 80-meter cubic chambers and a series of 8 vertical, spiral-shaped pathways. The team suggests these structures are 38,000 years old. That date completely upends the established timeline of the Fourth Dynasty, pushing the construction of Giza tens of thousands of years before the Old Kingdom. Claims of highly precise, ultra-ancient geometry directly fuel long-standing alternative theories that describe the pyramids as surviving technology from an advanced pre-flood civilization. Specifically, it revives a hypothesis explored by Nikola Tesla and later engineers: the idea that the pyramids were originally built to function as industrial power plants or energy-harnessing structures. To arrive at these extraordinary findings, the Italian researchers utilized an advanced satellite imaging technique called synthetic aperture radar, or ASR, Doppler tomography. Mainstream archaeologists and radar specialists vehemently reject the study. They point to a strict physical constraint: the technology used cannot see anywhere near that deep into the Earth. To test this 648-meter deep city, we must look past viral headlines, deconstruct the physics of SAR tomography, and examine algorithmic hallucination. Understanding the strict boundary between physical reality and a software data artifact is essential before attempting to rewrite human history. Synthetic aperture radar is a standard, highly reliable tool. Satellites and aircraft use it to map surface topography and track millimeter-scale shifts in the ground caused by earthquakes or landslides. The physical constraint of this system lies in its operating frequency. The radar waves used in these satellite scans operate at approximately 10 gigahertz. This diagram illustrates wave attenuation. When microwaves interact with limestone, they absorb and scatter. They do not pass through. Because of severe attenuation, radar waves cannot penetrate past the surface. There is a massive physical gap between the radar and the 648-meter structures. The researchers acknowledge they cannot see through the rock. Their workaround was to analyze the ambient microvibrations happening strictly on the surface of the plateau. They used Doppler tomography, a method that analyzes tiny frequency shifts in the radar's returning echoes to measure how the surface rock is vibrating. The team then made a massive deductive leap. They attempted to infer the presence and exact shape of deep hollow voids entirely based on how those surface vibrations propagated. Because SAR is physically incapable of seeing underground, the entire 3D model of the Giza complex relies completely on indirect mathematical assumptions rather than direct observation. Professional geophysicists map deep subterranean structures constantly for the oil, gas, and mineral industries, but they do not use passive satellite radar. The primary requirement for pushing an elastic wave through varying densities of bedrock is massive, active, low-frequency acoustic energy. To map structures at depth, professionals must forcefully inject energy into the ground. They use heavy vibro-sized trucks equipped with large metal pads. These pads violently vibrate the desert floor, generating powerful primary and secondary waves, known as P waves and S waves. These active low-frequency waves, typically operating between 10 and 100 hertz, can travel up to 2 kilometers deep. They hit subterranean rock layers and reflect clearly back to geophones placed on the surface. This split-screen comparison highlights the signal-to-noise ratio problem that completely invalidates the passive Giza study. Weak ambient surface noise fades out almost instantly in the crust, while high-energy active waves penetrate deeply and return clear structural reflections. The natural environmental noise at Giza lacks the energy required to travel down 648 meters, bounce off a hollow chamber, and return coherent structural data to the surface. Without a powerful active energy source, attempting to map perfect geometric chambers from ambient vibrations is physically equivalent to trying to hear a whisper in a hurricane. This leaves one final question. If the surface data lacked the energy to map deep voids, how did the researchers generate such highly specific 3D shapes? The Khafre project relied heavily on artificial intelligence. Human researchers did not draw the cubic chambers or the spiral shafts. An algorithm did. The AI utilized in the study was specifically trained to search for and identify structural anomalies. It was not programmed to simply objectively render raw physical data. This 3D field represents algorithmic hallucination. When a pattern matching system processes chaotic data with zero signal-to-noise ratio, it breaks down. Desperate to fulfill its programming, the AI finds false patterns, forcing random static into perfect geometric cubes and cylinders. These computer-generated models have not been verified by physical excavation, independent geophysical scans, or academic peer review. Relying on AI to interpret poor data is becoming a widespread problem in modern pseudo-archaeology. Sophisticated software renderings often create an illusion of precision, while masking a total absence of reliable physical data. The Giza underground city is a digital ghost. It is a hallucination created by software misinterpreting the natural vibration of the Earth. To understand what is actually beneath the Giza plateau, we have to shift away from digital hallucinations and look at the physical, verified archaeological record. Mainstream Egyptologists have aggressively rejected the 38,000-year-old megastructure claims as unsubstantiated fabrications that ignore decades of physical fieldwork. Real, verifiable tunnels and chambers do exist beneath the plateau, a concept experts refer to as symbolic subterranea. Excavations in the shallow bedrock have uncovered worker tombs containing pottery and stone tools. These finds establish a clear record of skilled human laborers living and working on the plateau, providing physical evidence that contradicts the hypothesis of advanced ancient machinery. The most significant true underground structure located near Khafre's pyramid is known as the Osiris shaft. This cross-section shows the layout of the Osiris shaft. It features a sequence of vertical descents leading through multiple specific levels carved directly into the bedrock. At the very bottom of the shaft rests a massive granite sarcophagus, submerged in groundwater. The archaeological consensus maintains that these tunnels served specific ceremonial functions, honoring gods like Osiris. They show no evidence of serving as high-tech, energy-harnessing infrastructure. Real archaeology yields tangible artifacts at depths accessible by human hands, not perfectly geometric 80-meter voids detected passively from space. While Giza undoubtedly still holds secrets beneath its sands, discovering them requires the rigorous physics of actual excavation and active seismic surveying, not the algorithmic misinterpretation of ambient noise.